number line. And the first thing that we want to be able to do with the number line is to translate it into interval and inequality notation. So interval notation is the parentheses or brackets with a comma in the middle and then another parenthesis or another bracket to close. And then you might have multiples of them, and so you would have unions of more if you have a couple. In this case, we will, so we'll want to have two parentheses, and you might have parentheses or brackets, parentheses, what have you. So that's what it looks like to do an interval in general. Now, what we want to be aware of is that these parentheses or brackets have meaning. Parentheses are open dots. Brackets are closed dots. They then further correlate to these less than or equal to or less than not equal to symbols. So that is a less than or a less than or equal to if you're doing a bracket. Okay, all parentheses are the red was not a good choice there, are a not equal to. So it could be greater, it could be less than, don't know here, and then it's greater than or equal to or less than or equal to if it's a bracket. Okay, now this U, the U stands for union, and a union is rewritable as an or. Now, what you're going to find, and a lot of people made mistakes before, is that when you're on interval notation, you always use the union symbol here if you're needing two sets. If you're in inequality notation, you always use the word or right here if you need it for two sets, or it might just be one in both. But or never shows up over here in interval notation. It'll mark you wrong. And the union symbol does not show up down here for the inequality notation. Although they mean the same thing, we're writing it differently. And so we don't want to get the wrong answer because we were trying to write the right thing. So what we need to do now is to infer from here what I just wrote, how this shaded, if you can't tell, that's shaded there in green, to the right of 7 and then to the left of -6. So our job is to write that in both forms. In interval notation, you should start at, it's always left to right with a comma in the middle and then brackets or parentheses for interval notation. Inequality notation is a little bit different, but all we have to do is say leftmost to rightmost for our interval notation. What is the leftmost thing on this graph? This little number line. Negative infinity specifically, right? Negative infinity all the way to the left. And then, so that's the leftmost thing, comma, the rightmost thing of this first part is -6. So what we do with that is we put parentheses on the negative infinity because we don't touch negative infinity. You put parentheses on things you touch, or sorry, don't touch, brackets on things you do touch. -6, we actually don't touch either because there's a open dot there. So open dots give you parentheses, and then anytime you do infinity, positive or negative infinity, it's always a parentheses, never brackets. So that's our leftmost set, and then our rightmost set starts here. In the middle, we want to use the union symbol. So we put union, and then we need a little more space here. So I'm going to erase this. So now we need to start again at 7, comma, it goes forever to the right to infinity. Okay? That's how we do interval notation. And now we're going to do the inequality or set notation. Well, set notation is a little bit different, but inequality notation uses the alligators, if you will. That's these guys right here. So now we need to say the same thing, but with alligators. And the way that you do that is you say x is everything left of -6. So you just say less than -6. And then you use the word or. X is everything that's bigger than 7. And that's your inequality notation. with the word or in the middle. So type that in there and you should get a green check mark. All right, on the second example, you notice that there's green shading between two numbers. This is a conjunction, an and conjunction, where you're combining two thoughts. It's bigger than -7 and less than 6, but we're not going to put it as two separate statements. We want to combine it all at once. Now, in interval notation, it's the easiest way. You just do the leftmost, comma, the rightmost value. And these are solid dots, so we're going to use brackets rather than parentheses like the last problem. So our leftmost value is -7, comma, the rightmost value is 6, and I just need brackets on that, and I'm done. I have listed the domain of this green shaded graph. And now below, for the inequality notation, I need... again, I said earlier, it's basically saying x is greater than or equal to -7, and x is less than or equal to 6. The issue, though, is we don't have an and option, and I don't think it'll let us type it. But there's a better way to do ands, and that's to write a conjunction statement where you're saying basically x is between. It's less than a number or equal to, and it's greater than or equal to a number. So x is literally between two numbers. In this case, it's 6 is the upper bound and -7 is the lower bound. So if you write it all together like this, what you're saying is that x is all these things in the middle of -7 and 6. So you write x between anytime the shading is between. So you got two values, dot here, dot there, shading in the middle. This is what you make it look like. It's an and conjunction, but we don't have the and option. All right, on this example 3, it's very similar to the last problem. The difference now is both of these are open dots. And so how that translates for us, when we do the interval notation, is still leftmost, comma, rightmost, but the difference this time is we're using parentheses on each bound because they're both open dots. The leftmost value is -5, so we say -5, comma, the rightmost value is 0, and then it's just parentheses on both. And that is the correct interval notation. Now, that is not to be confused with the coordinate, the x, comma, y value of -5, 0. That is not the same thing. That looks like a coordinate, doesn't it? And a lot of students mess that up. And the only difference between that and a coordinate is context. The context is we need a domain. So this is a domain interval that's saying how far left to how far right you went versus the coordinate -5, 0. And it's tricky. There's not anything other than saying context that is the right way to clear that up. An inequality notation for this one is going to be just like the last one where we say -5 and then put x in the middle and then have 0 over here. And what you do is you say -5 is less than x and x is less than 0. That is the and conjunction statement, and it puts basically -5's here, 0's here, and x is everything in the middle, is how that translates to the graph. And here the dots are open, so that's why I didn't put an equal sign in these two locations. So it's just that leaves for the open dot. Right, on this fourth one, what we see is solid dots pointing out both directions. Okay, so the solid dots are going to change the interval notation. So very similar to the first example where we start leftmost at -infinity and we're heading all the way to -8. This is my left-right situation. So the first coordinate is going to, or first interval is going to be -infinity, comma, -8. And what's different this time is you put a bracket on it. And just like before, we always use the union symbol rather than the or for interval notation. So a union, and then we pick up again at 7 here. So we go 7, comma, infinity, and we use a bracket on the 7, and on the infinity we use parentheses. Never ever use brackets on infinity because brackets means you can be equal to the value. Well, you can never be at or equal to infinity. That's impossible because as soon as you think you're at infinity, infinity shoots infinitely far away from you and you keep on running. So it doesn't work. Inequality notation, very similar to the example 1 again. You just say x is less than, not equal to, or sorry, and equal to negative 8. And then you use the word or. X is greater than or equal to 7. All right, so on this fifth example, what we're doing is we're given the inequality notation right here, and our job is to translate from the inequality to the other two, the interval notation and the number line. Now, my brain goes, I've tried to train my brain apparently to go to the number line. And so what I like to do is to go to the number line first. So let's go to the number line and try to track this. What this shows visually is that x is between negative 2 and 10. So I want to come down here and start at negative 2 and drag a dot from negative 2, if I can click. It's not letting me click. Maybe I probably have to answer interval notation first. That's not right. No, it's click and drag, right? Let's try it again. Negative 2. Oh, yeah, there we go. So negative 2 to 10. I just had to click, hold it, and drag. That was the issue. Sorry, it took me a second there. So click, hold, and drag from negative 2 to 10. And you'll see visually this is what this statement up here says. Okay? Now, the interval is very convenient here. The leftmost value is negative 2, comma, the rightmost value is the 10, and then your choice just has to be that these are supposed to be brackets as opposed to being parentheses, because these, anytime you have an equal line underneath there, that's a bracket. Anytime there's not an equal line, it would not have a bracket, it would be parentheses, and vice versa. All right, here we are, example 6. So we've got an OR, which means we're going to end up using a union symbol for the interval. And then down here for shading, it means that we're going in opposite directions. This one's going that way, and this one's going to go that way to the right. So this, on the number line, is where I'm going to start. We'll start at positive 8. And then what you do is you drag from 8 all the way to the left, and then as soon as you get to the end, it turns into the arrow, and you need the arrow to show that it keeps going to the left. And then we pick up again at 11, click there, and then drag all the way to the right, and then it turns into an arrow pointing right. You need both of those arrows to happen, and that'll be the correct graph. Now for the interval, since we're going to the left to negative infinity, we need to start with a parenthesis, negative infinity, always parentheses on infinity, comma, we're stopping at 8. Now, I forgot one thing. This is supposed to be not an equal sign. So down here, this needs to be an open dot. So what we do to make it an open dot is you click it, and then it changes from closed to open. And the same thing needed to happen in front of the 11. So we click that one, and now it is open. So, and my brain was thinking about that because I was about to put a parenthesis or a bracket on 8. And that's what reminded me it needed to be an open dot down here for parentheses on 8. And then parenthesis opening on 11, comma, all the way to the right to infinity, close the parenthesis there. All right, here on example 7, we've got another OR statement. The difference this time is that there's an equal sign, and so it's going to be solid dots. So as I come down here below, I'm going to go ahead and graph it first again. Apparently that's my strategy, to visualize. So I start at negative 10 and then drag to the left. This time I'm going to keep that as a closed dot. And then we go to negative 1 and then drag to the right because it says x is bigger than negative 1. Now, a quick little thing I hadn't mentioned earlier. If your x value is on the left-hand side of the alligator, this will help you know which way to point. So that should be pointing left from negative 10. And right here, this is telling you from negative 1, you point to the right. So that's supposed to be a helpful strategy. It's only helpful if the x is on the left-hand side of the inequality symbol or the alligator. Now down here below, the interval notation then would be from negative infinity, parenthesis on that, no brackets there, comma, negative 10. And then it's going to be a bracket this time on the negative 10 because we do have a solid dot. Notice the difference from the last problem here. Now we have union again, bracket on the negative 1, comma, infinity, parenthesis on infinity, never brackets on infinity. This eighth example, we're getting now a interval setup, and then we've got to translate that to an inequality. So the inequality from here, and again, you can go inequality next or go graph next, whichever way you want to go. This is essentially saying that x is all the values left of -6. And this part, this right side, is saying that x is all the values bigger than 6. Sorry, I was going to infinity there. The word in the middle, you use or instead of the union symbol when you're doing the set. So our inequality is x less than -6, not equal to because it's parenthesis, or x is greater than 6. Sorry, I'm going to turn my arrow there into a 6. The number line, I like to look at the inequality notation. It makes sense to me out of here. It's basically saying start at -6, and the arrow is pointing to the left from there. That's what this shows right here. And then from 6, you shade a right arrow. So it's basically like this arrow is saying from 6, you shade to the right from there. And that should get you your green check mark. And make sure that these dots are open dots, not closed dots, because we just said it was an or statement with these alligators do not have an equal sign underneath them. This was parentheses, not brackets. So make sure you have open dots. We have brackets this time. So the last problem was open dots. This one is going to be closed dots, still pointing away from each other, just like the last one. So the inequality symbol is going to be x is less than or equal to -5. And then you translate the union symbol to be or. X is bigger than, or again, equal to, because of the bracket there on the 0, 0. Down on the graph, again, we're going to keep it this time with solid dots. -6, and then arrows to the left. Or sorry, -5. I said -6. -5 to the left, and then from 0 to the right, like that. All right, last example of this type, where we are translating between the types of brackets and notation. So this one we have brackets for our interval, and our job is to recognize that means that x is between -9 and 5. So down here it's going to go from -9 all the way over here to 5. And the shading is everywhere in the middle, is what's going to happen in a second. So the inequality, this is the one that a lot of us struggle with. It's right, -9, and then it's 9 is less than or equal to x, which is itself less than or equal to 5. So the way that the setup works is it's saying x is between, just like I just shaded over here, -9 and 5. And these equal signs mean that it's going to be solid dots down below, but it can be those end values. So not -9 and 5 bookend where x is going to be. So now down below, I'm going to actually do the graphing. So I'm going to click at -9 and then go all the way to 5. And that should be my correct graph. All right, so here's one more cool example. This is where people struggle, is they look at that and they're like, oh, that's the coordinate -711 because it's got parentheses on it. But it's actually an interval where the endpoints are just open dots. And so down here on the graph, what that's going to mean for us is that I click at -7, and then I drag it over to 11. Oops, I didn't drag far enough. Let's try that again, see if I can't. I can't. Darn. I got to undo it. Okay, let's try it again. -7 all the way to 11. And then you just change the endpoints to be open dots instead of closed dots. And then the next part that people don't like is the inequality. Anytime it's just a set interval from here, we start at the -7, and then it's less than, not equal to, because they're parentheses, x, and then less than but not equal to 11.